go K kinetic mu. Isn't kinetic mu sort of a funny thing? It makes me laugh anyway. Does it make you laugh? A little bit. There we go, right? Okay, so we added 0 and 250 and 500 and 750 and 1,000, didn't we? Right? And the total is just going to be, I'm just going to say it equals this plus 245. Isn't that what we said the weight of the block was? Right? So you're going to have to add the weight of the block. I'm so lazy that, I mean, you could obviously just add those up and just put those as a total weight. I'm so lazy that I don't even want to do that, right? Okay, so I'm saying plus 245. How do I make all of them below that the same? Drag that baby down. I drag the corner handle down. You see that? Boom, right? Now, how do I figure out the weight and what's the difference between what I've got there, the total mass and the weight? There's two things we've got to look out for. Got to convert to kilograms. And so that's divided by 1,000, and then how do we had to multiply by 9.8, right, to turn it into the weight. We want to turn it into the weight in newtons, right? So I'm going to say that this guy equals this guy divided by 1,000. Is that 1,000? That is 1,000. And I'm going to multiply by 9.8, and that should do it. It's crazy, huh? So there they are. When you do it, you should have. They should be on the order of like 10 newtons or something like that, right? That's what it should be. And then let's type in our fudged data here, right? 1.1 and 1.9 and 2.8 and 3.5 and 4.2. Don't turn this in as your lab. That'd be pretty gutsy, wouldn't it? 0.6 and 1.2, 1.8. Not gutsy in a good way. Gutsy as in like I sit down with you and the dean of students, and we discuss this, right? Okay, and then so here we go. Are we good? Okay, and then the deal with this lab is that you're going to do this whole thing on maybe the countertop, and then you're going to also do it on some other surface. So you could do it on the floor. You could do it on the surface of a desk. You could, and this is a real slick thing, you just take a piece of paper, tape it to the counter, and slide them on the piece of paper. Okay, that's actually one of the better things to do, because if you're sliding it on the paper is guaranteed to be a pretty clean, uniform surface, right? So, but you need to do it on, I would recommend doing the counter and then just one other surface. You have to do some other surface. And if you do more than one other surface, I suppose I could give you extra credit. Doesn't that sound like a good deal? Yeah. Okay, so what does it say to do? It says make two graphs of the force of friction versus the weight, one for the paper data, one for the table data. So here in the lab, I tell you to do it on paper and on the table. You can pick any two surfaces, but here's the caveat. Take your 5.2 Newton force scale. If whatever surface you pick at 1 kilogram added has too much force, then don't do that one. Yeah? Just a thought there, right? You want to do something that you can use that 5 Newton scale on, right? Okay, so now let's calculate, let's actually make those graphs, right? So I have them like this. I'm going to select all of this. Do you see that? So I'm selecting the weight and those two forces of friction. When I do that, what it's going to do is, well, it's going to make the leftmost column be the x-axis. The right two are going to be two different things on the y-axis. Okay? So it's exactly what we want. Click the chart wizard. And it's not a line graph you want. It looks like it's a line graph, but it's actually this guy here that doesn't look like anything, right? It's the XY scatter, so do that, right? And the best one is just the one with the points. Don't do the one that connects the lines. The default is the best one. Okay, and there they are. Look at that. We fudged some pretty good data, didn't we? Right? Okay. And so I'm going to go next. And the title, what should we title this? Mr. Drumhiller's sock drawer. All right. You're going to give it a more meaningful name, but that's a good one. What's our x-axis? The weight in newtons, right? It's in newtons, okay? And the y-axis is force of friction. Force of friction, that's just in newtons. That's what we measured, right? Okay. And then next, there's two choices. Object in mix puts it as something that floats on top of the spreadsheet. I think if you want to show the data and the graph, that's probably the best thing. but I'll let you mess around with it. We don't need this legend here. I'm just clicking it. I'm hitting delete. Okay? And I'm going to put this guy over here. I'm going to make it a little bigger. I'm going to deselect the graph. So do this. Please do this, right? Deselect the graph and do a print preview. Right? And this will tell you whether you're spilling onto other pages. I can make it a little taller, can't I? Yeah? And now notice it's telling us where the graph, where the pagination is, where it's going to break the pages. Okay. I can make it a little taller. That looks good, doesn't it? Hark, a messenger. He is not here today. It's very sad. I'm sorry about that. Okay. I'll try to not let that happen again in the future. Okay. So here we go. Then it says, what does it say? It says, for each set of 5 points, draw a best fit straight line through the points. Didn't I promise you a right click? Yeah. I think I did. Earlier I promised you a right click. So you have to right click on a point. Okay, so right click, and then you want to add a trend line. So right click, add trend line. Write that down if you're not going to remember it. Okay, and it gives you all these things, right? We want a linear line. There are other lines, right? Choose linear. Before you click OK, though, choose options. And see here it says display equation on the chart. If you click that, it will display the equation on the chart, which is what you want because we want the slope of the line and the equation's in the slope, yes? Okay. You're going to see all this one more time. So this one here says that our coefficients of friction right there are 0.3184. That's the slope right there. The thing that is multiplied by x is the slope. Can you remember that? It's y equals mx plus b. Your math teacher taught you this? And I'm just trying to wake people up here. Okay. And then you go here, right? And you go into this guy and you right click the point. It's pretty exciting. Are you excited about this? I'm excited. Okay. So again, I'm right clicking a point. You have to click the point. You have to actually hit the point. It's not like close to the point or between the points. Right on the point. Right click, add trend line. Options, you want choose linear if it's not chosen. Click options, display equation on chart. Boom, there it is, right? There's our second one, yeah? Isn't that beautiful? The graph, she is beautiful, right? Okay. So there we go. That's our graph. Label it with its slope. Well, there it is, right? Isn't that good? That's the right click, add trend line. Yeah, and then display equation shows the equation. Okay, are we good so far? Yes, good so far. Okay, now, hold on. I don't know if you notice, but those of you who are awake were noticing that I skipped step 6, which was to calculate the coefficient of friction for all of these guys, right? So let's go back up here. Notice that I have the static mu and the kinetic mu, right, that I need to calculate. So to find the static mu is going to be, mu is just going to be the force of friction divided by the weight, right? So all we have to do is divide the force of friction by the weight. So the static mu equals the static force divided by the weight. And we can fill that down. There we go. Okay? And the kinetic mu equals the kinetic force divided by the weight. Now, here you can see that I made up the data, especially for the kinetic friction. For the kinetic mu, I made up a straight line, and those all agree pretty well, don't they? But check out the static one, right? Real data is not going to look like that. What does it do? It steadily increases. Yeah, it's because I made up the data. It's not real data, and so they're not all agreeing. Notice also that this coefficient here does not agree with this number here, right? So this static coefficient should be the slope of the static line, yeah? So we're getting the coefficients two different ways. We're finding the slope of the line, that should be the coefficient of friction, right? But we're also we're calculating it 5 different times, right? These should agree with that, but they don't. This should agree, these guys here should agree with this guy here, and they do, yeah? And that's because I made up much better data for the kinetic one, didn't I? Yeah?
Yeah, so yeah, you did.
Yeah, there you go. Right. So there's that. Are there questions about that so far? It's like I don't have questions. I am asleep. Okay. Make sure your lab has all the following data when you turn it in. You need to have your